Okay, so this is Space Wars, right? It's a two-player game, 2 players on the keyboard at the same time. Keen, do you want to come over here to this side? I'll just explain the controls, okay? So it's A and D to move left and right. W will go thrust forward. S is to shoot. E is the hyperspace. You've only 5 hyperspaces, right? It's a 2-player, what you call it, like a deathmatch style game, okay? So your keys are J, K, L, and I. So I is thrust forward. This is left and right. K is to shoot, and O is the hyperspace. So you can use your left hand and your right hand, and then press space to begin, and you'll see what the game is all about. Maybe I'll turn the lights off so you can see it. This is what we're going to make. Go ahead and press space there. We'll have to play a few rounds of this, okay? So this is the game. 2 players. Yeah, there's gravity in that sun pulling you towards the sun, and if you crash into the sun, you die. Huh? Oh, you can't see it on the screen there? Oh, that's tricky. So you got to shoot each other. Yeah, you got 5 lives each to start. Gravity affects the bullets, and it affects the 2 ships as well. If you get pulled in by gravity, if you get pulled into the sun, you die, and if you obviously get shot, you lose a life as well. Everybody starts with 5 lives. Player 2 is the winner. Who's player 2? Hooray! Okay, go again. No, go again. Come on. This is practice level, huh? Oh, did you hyperspace? Yeah, you can hyperspace. If things get hairy, you can press hyperspace. And you've got 5 hyperdrive things. So it just basically makes you respawn somewhere in the center of the screen.
Should be an ammo capacity. Seems like there's a lot of bullets on the screen.
Yeah. You can't get hit by your own bullets as well. So the green person can only get hit by the red bullets, and the red can only get hit by the green bullets.
They have a respawn timer thing. They have a respawn thing. When they spawn in, they don't take damage.
Yeah, you're 5 seconds before you die. Before you can take damage.
Yeah. And how do you use the array list when you delete an object from the array list? That doesn't cause FPS lag on your screen. I couldn't get around that.
You don't have that problem.
I had that object in mind, I couldn't get around it.
Yeah, we have
Exact
lots
same
of
problem.
objects, so it starts really slowing down.
Okay, I'll have a look at it. Who else wants to go? Can I get 2 other volunteers up to have a go?
Yeah, good.
Come on. Yeah, come on.
Update this for the Android. Apparently that dust thing also on the 20 patch.
What does
The dust, all the dust.
Oh, another one bites because
Why did the people not have lives? They're only 1 life. You only have 1 life too.
Yep. They replaced all their shields with bullets.
You can make them more just as OP. Oh, make them the same color as the enemy one, so you don't know which one they're shooting.
No, just why?
That would be interesting.
I think I have all my classes are compatible with that game. I could just copy it away here and make this. What? Just
Alrighty, if you're still working, that's fine. But other than that, just have a look up here. So just set up my sketch like this: size 500, 500. X equals width divided by 2. Y equals width divided by 2. W equals 20. H equals 20. And I've declared these variables down here for the x and y for the width and the height. So we're going to draw this shape using 4 lines. So if you think about the coordinates of the bottom left-hand corner here, so we'll start off and we'll draw the first line here, from here over to here. So let's go line, and now we have to figure out what's the coordinate of the bottom left-hand corner here. So it's going to be x minus the width divided by 2. Does that make sense to everybody? Because it's halfway over from the width. So it's x minus the width divided by 2. So, you know what, let's even declare a couple of variables here. Int half width equals the width divided by 2. And we'll do the same thing for height. Int half height equals the h divided by 2. Just so that our line code doesn't look so messy, that it's got lots of variables being calculated inside the parameters to line. So first of all, let's take x minus half width as the x coordinate, and it's going to be y plus half the height. And then we have over x and down y minus half the height. And that's our first line. Okay, we'll do the second line. The second line then we might take as being this coordinate here down as far as this coordinate here. So this coordinate here is going to be over x and down y minus half height. Yeah, minus half height. And then we have over x, over x plus half the width, and down y plus half width. Okay, and then we have our two inner lines. So this one is going to be line. So we pick this coordinate here again is going to be x plus half the width, and then y plus half the height. And then we're going to go to x and y, because we go to the center of the object. And then the final one is going to be x and y down as far as x minus the half the width, and y plus half height. So I think that's it. Let's just run that and see what happens. Yay, there we go. So that's it drawn using 4 lines. So I'll just leave that code up there for a sec if anybody wants to take it down before we continue on. Did everyone get something similar to that? Anyone? Does everybody understand how those numbers are calculated? Does anybody want to ask any questions before we move on to the next thing? Yeah.
Can you not do it in one line? Like line x by y and divided by 2 and the width and height?
You still need 4 lines, yeah? Because you're drawing 4 lines.
Just draw 4 lines because you divide it.
You can take this code here, and instead of declaring these variables, you can do the calculations in here. But you still need 4 lines, because you're drawing 4 lines. You need 4 line commands. Is that what you're asking? Yeah, you need 4 line commands, because each line command draws 1 line. And, so if you remember how line works, it takes 4 parameters, which is the x1, y1, x2, y2. Alrighty, so we need 4 of them. Alright, I think, unless there's another way to do it. Did anyone use shape?
There's 2 triangles.
How would 2
Okay,
triangles?
2 triangles and a rectangle to get rid of the bottom line.
Oh, messy. No, 4 lines, I think, is the most straightforward way, okay? Alright, so, next thing we want to do, everybody, I'll leave this up for a second. Do you guys all know how to get keyboard input in processing? Does anybody need to know how to get keyboard input? So there's 2 variables that we can use to get keyboard input. We can go key pressed Okay, that's a Boolean flag that will tell you whether a key was pressed in the last frame or not. And
Isn't that also a function for that?
it is a function as well, a method. Yeah, definitely. We can use that one as well. We'll just keep it simple for now. In fact, I'll show you the two ways. So you can go if key pressed, and then, isn't that the variable you check? And then you can check to see which key was pressed. Okay, so let's try and make it so that if we press the A and D keys, the ship is going to move left and right. And if we press the W and S keys, the ship is going to go up and down. So what will we be doing? What variables will we be modifying?
WASD.
What's that?
WASD for movement.
Sure thing. What variables in our sketch will we be modifying? The X and Y coordinates. Okay, that's your next task. Go and make that bit.
I mean, shift the same.
Alrighty, let's do this next thing. So I'm sure some of you have figured this out already, okay? If key equals, let's do the W key. What do we want to do? Y equals Y, let's say minus 1, for example, for now. You know what? How many people wrote if statements for this? How many people wrote a switch statement? Okay, so let's use a switch statement, because I think it's slightly less code if you write a switch statement. Switch. Switch key. Just for a bit of practice of doing something different as well. Takes W. Cool. So that's our switch statement there instead. And what have I forgotten to do? Clear the screen. Let's do background 0 and stroke 255. Okay, cool. Alright, has everyone got something similar to that then? And does anyone want to ask any questions about that before we move on and do the next bit?
Why not use X++?
No good reason. I should really use X++, doesn't really matter.
How
Means
to
the same
do,
thing. I probably don't want to do X++ because I want to control it using speed, so I do X plus equals to speed, probably multiplied by the time. So,
How do you say make the ship rotate, like press D a little bit?
Sure, we're going to get to that, right? So we'll get to that in about 20 minutes, hopefully. Okay, is everybody happy with this bit? Hello? Yeah?
Yeah.
Cool. Alright, let's do the next thing. Okay, so the next thing is, I'm sure you're going to get the sense at this stage that if we continue along this path of just building our program up like that, then we're going to end up with one kind of big massive sketch, right? And that's not the way we like to design software. We like to design software so that we have smaller pieces of code which can be reused in different ways, right? And this is a concept in programming. This is one of the big concepts in OO programming is this idea of encapsulation. So encapsulation kind of means that we try and look and see what do we need to store and what do we need to do with the information that we're storing, and we try and group those two things together. So encapsulation basically means that we take the data that our program works with and we take the methods that our program needs to operate on and we group them together. Now looking at this thing that we're trying to make here, right, we can see that there's clearly some sort of a ship on the screen. So it makes sense that we try and take the data that this ship needs to move and the methods that it needs to move, and we try and group them together. That's the kind of the idea of classes. Is everybody okay with that idea? And just like look up from your computers for a minute, because this is important. I may ask you for a definition of encapsulation, or you might be asked to give an example of it in an interview, and that's basically what it means. So, the next thing then, okay, so we have this concept of encapsulation where we try and take the data and the methods and we group them together. Then we look at what we have to sort of manage in our piece of software that we're making, and we try and make what's called a class that encapsulates some piece of data and some of the methods that it needs to operate on. Okay, so the definition for a class is just a grouping of data and methods together, all right? Now when we look at this example here, it makes sense that we try and group all the stuff to do with the player into something called a player class. So let's make a player class here. And then we need to ask ourselves, well, what's the data that we need to manage the player class, and then what are the methods that the player class needs? So the first question then, based on this little example here, what data does the player class need? Looking at the program that we've just wrote, if I wanted to encapsulate all of the stuff to do with the player into a class, what data do I need to know about the player? Its coordinates, so the x and y coordinates, and the width and the height, and the color. Alright, so we'll group all of that information together, okay? Now, what methods does the player need? It needs movement methods, alright? So, it helps maybe when you're thinking about objects and classes for the very first time that you kind of relate it to things in the real world. People often do this. It kind of works to a certain extent. It's not exactly how our brain works, right? But if you think about something like a car has a whole load of data. There's a certain amount of fuel in the fuel tank. There's you know, the color of the car, the number of wheels, etc. And then there are certain things that cars do. So cars can drive. Alright, so if I was making a class to encapsulate a car, I would probably include a method called drive on it. If I'm making a similar piece of software and I decide I want to encapsulate some data about dogs, does a dog have a drive method? No. What methods would a dog have on it? It would have stuff like bark and eat and things like that. You get the idea of classes? Alright, so we try and encapsulate the behavior and data together. And this is what it looks like in processing. You can put all of the code into the same sketch, but whenever I make a class in processing, I like to put it in a separate file. Okay? And when we come to do Java, you know, pretty much in probably semester 2, where you have to put all your classes into separate files. The file name has to be the same name as the class name, so it's good to get into the habit of doing that now. So let's take our code that we currently have, and we're going to restructure our code into a class that encapsulates the behavior of that ship. By the way, when I take my code and everything works, and I go and change everything around to kind of order everything and make it neater, what's that process called?
Optimization.
Not optimization as such, because we're not necessarily going to make our program more efficient. We're just going to make it easier to read. Does anybody know what that process is called? And there are tools usually built into IDEs to do this, or to help you to do this. Does anybody know what it's called? It's called refactoring. Okay, so write that down as a definition. It basically just means restructuring your code around to make it better organized. So we're going to refactor this project, and we're going to refactor it to take all this stuff out of the main sketch and put it into a class. Alright, so watch what I'm doing here, and you guys just follow along for now, okay? So I'm going to click New Tab here. So I've just clicked this thing here and got New Tab, and then in processing it asks you to give a name to your tab. So let's give this name the, should we call it Ship? For Spaceship? Or Player? What do you think? Let's call it Player. So then I click on OK, and I get a new tab. This is a new file called player.pde, right? And if you look at the folder, you'll see that it's there. There's an extra file. And now let's put a class in here. So this is what the syntax for class looks like in processing. We've got a new keyword here, and this is the class keyword. So now let's call our class Player, like that. And the convention in Java, or in most programming languages, is that the class name begins with an uppercase character. So get into the habit of, whenever you're making classes in your projects, to always make the class with an uppercase character. Is that okay with everybody? So we've got a Player class, we start with an uppercase P. And then open and close curly brackets like that. And then it doesn't matter what order you do this stuff in, right? You can do it in, put your fields first and then put your methods, or your methods and then your fields. It doesn't really matter. let's put our fields first of all, okay? I think, yeah, here's a question for you. The x and y, should we make those integers or floats?
Floats.
Okay, why
Be
floats?
more precise, it'll make it look like it moves smoother.
Sure, yeah, because we eventually will need to make them integers to draw them on the screen, but when we're doing our movement calculations, it makes sense to make them floats. Because we want to do stuff like multiplying the time delta, which will be a very small number, and do like little physics calculations, like calculate how much it's going to move in each frame. So let's make them floats, right? So I got float x and float y. And we also have width and the height. Let's make them all float, right? Float w comma h. And now let's put on some methods. Okay, so the first method we're going to put on this class is called the constructor. So there's some rules with the constructor for a class, right? The constructor for a class, it's a method like any other method that's on the class. So let me just write this up here. A constructor. You know what? I'll write a little comment here. Okay. So let's just put the constructor for this guy. So the first thing to say is that you can have as many constructors as you like. The constructors can take parameters, and these parameters are values that are passed into the object when the object gets created. Okay? The constructor is a method which gets called whenever we create an instance of this player. Alright, I'll show you what that looks like, and we'll step through it, and I can show you it being constructed. So, the other thing about a constructor is a constructor never doesn't have a return type. Okay, so in this example here, class is called player, the constructor has to have the same name, and you don't put void player. If you put void player, your program won't compile. It has no return type, and you don't specify a return
It works
type.
when I did it before.
What's that?
I did it in the assignment that works using void.
Uh,
It works using void.
Sure, yeah, we'll double check that. We'll try it, but it shouldn't compile. I don't think it will compile if you put void in.
It works. It's I just
No
send
problems.
it.
We'll try it in a minute, right? And just see what happens. Then the other method that I put in this thing was the move method, right? So this one can have a return type. So let's go void move. Open and close brackets like that. Let's take all this code here from here, and let's take it out of this class here. And I will put it into the player class instead. And what we usually do in a constructor is set initial values for the object. So let's set some initial values for the object. We take all this code out here and put it into the player constructor instead, because this is all stuff relating to the player. So we'll set its initial values in there. And then we can take all of this code out of here. And we'll put it into another method on the player class called draw. Okay. And then we'll just make everything line up, and then I'll show you what the final thing looks like. So all this stuff needs to be indented. Cool. Alright, so there's our first player class, right? So let's just recap on what we've got here, okay? So you go class player, uppercase P, open curly bracket to begin the class, and then close curly bracket to end the definition for the class. The first thing I have here is the fields. In other words, the data that the player is going to need to operate on. It's going to need the x and y, the width and the height. We should probably put in the color as well. Why not? So there's the color, and let's say that the color is going to be equals to COLO4. Let's make it a white one, 255. So we've got a white player. Okay, so that's my constructor. Same name as the class, no return type. Next thing I have is a draw method here, which is basically going to draw the object. So let's go stroke, color, like that. And then I have the code to actually draw the object. And then I have some more code in here to move the object if a key is pressed. Okay, now if all being well, the program will compile. Let me just make sure there's nothing in there again. Yeah, let's get rid of width and height from here. and X and Y, because all of this now is going to be encapsulated inside our player object. And now when I click run, C-O-O-U-R, let's make these floats, keep everything as floats. Ta-da! We get nothing on the screen, okay? So before we go and instantiate that, I just want to make sure everybody's program compiles. So take a few minutes to get your program up to the level that this is working at. And
Do you also have a void display as well? That's what I usually use.
void display.
Yeah.
Sure, yeah.
That's what I use for drawing it.
I put it inside a method called draw.
Oh, you call it draw?
Yeah, it doesn't matter. You can call it display or draw. It doesn't really matter.
What should I do with the key press?
I
Okay.
put that inside the move.
Since I use the actual void key press,
Ah, so that's, yeah, slightly tricky.
I would
Because it's slightly more difficult then to encapsulate it, right?
like to do this. Just call something. Call a file player interaction. Just put it here.
No, I wouldn't do that. What you can do is just,
It reads this file. Whatever's in here is all.
Send a parameter called key, maybe.
sure, yeah, that's not a bad one. Write a method on the player class that takes the, called move, that takes a parameter of the key, and then just call that method from the
Put that in the move.
Yeah, you could pass it into the move, yeah, pass it in as a parameter.
If key press.
Yeah.
So we're just doing technical things in there.
We can all call. I suppose.
Apparently the way he's doing it, you can't do
We can move all our calls to the function. We can move all our calls to the can send in parameter.
Okay, does anyone want to ask any questions about that? Just get your program to compile it. If anyone has any problems getting your programs to compile, put up your hand and I'll come down and take a look at it for you. But just be clear, we've got a player class with a constructor, a draw method, and a move method. The draw method is going to draw the player, the move method is going to move it based on the keys. And then your program should compile, but it won't do anything. Because we're missing one little link. We've got to link up the sketch with the new thing that we've made. If you need me to zoom in on any bit, just put up your hand or just shout out and I'll zoom in on any bit, okay?
What is this?
Okay, how many people have this done? Put up your hands. How many people are still working? Okay, we'll move on to the next thing, okay? Just make the program compile. So, now we've got a draw method and a move method on this guy. The next thing to do is to... That's already video. Okay, the next thing we want to do is create the link between the sketch and this player class that we just made, okay? So, if everyone can just look up for a second, right? When we describe the player like this is basically a template for what a player is going to be, okay? So, at this point, we've described the player, but we haven't actually created an instance of the player. So there's this concept of a class, and then when you create an instance of one of these classes, it's called an object. So that's the relationship between object and classes. A class describes what an object is going to be. An object is actually the thing with some memory allocated that you can manipulate and that can run it. Alright? So at this point, like I say, we have this player class, but we haven't actually created a player object yet. So let's come back over here to our sketch. And this time, let's go player, like this. This is the first thing we do. So this now says that there's a variable called player, and its type is going to be this player class that we just previously described. Is that okay with everybody? So one slight difference between this and what we call primitive types in Java is when I do player like this, it basically says the player is going to reference an instance of the player class, but it doesn't at this stage allocate any memory for the player. So the one last thing we need to do is we need to instantiate the player, and you do that by doing player equals new player. And all of those steps are necessary for us to create an instance of the thing that we described in the player class.
Is it a good idea to call your instance the same as your...
Very good idea. Yes? So it's a good idea to call it the same name as the class. If it's a player, why would you call it anything else?
So to avoid confusion between the instance and the class?
Sure. So the confusion is avoided by the fact that, and the convention is usually that the class name begins with an uppercase character and the instance begins with a lowercase character. Alright? So, yeah, does everybody see that? So now I go player equals new player, player. And these things need to go together. When you do the first bit there, player, if you don't do the second bit, you get what's called a null pointer exception. We'll show you what that looks like in a minute. Next thing I need to do is I need to call the methods on the player class. So down here in the draw method, I'm going to call player.move and then player.draw. So that will call the move method on the player and call the draw method subsequently on the player. Don't be deceived, right? Just because you call something draw in a player class does not mean that the method gets called automatically. The only methods to get called automatically are the methods on your sketch class or on your sketch file. So setup and draw will get called automatically on your sketch. They won't get called automatically on any objects that happen to have methods called setup and draw. Yeah?
Would be better than keeping the function in the actual sketch itself, so that it's a key construction and it relates back to
I'll tell you what, we'll actually build up to doing that, and we'll do it using the press thing because it's better. You actually need to do a slight trick to be able to track multiple processes. I'll show you how that works, okay? We'll build up to that. At the moment, I just want to get the concept of approximation. We'll try and make the player manage its own draw, player manage its own draw. We'll continue with that. Alright.
And bread.
No. In fact, if you do, let's just test that. I did say that if I go white player, I would get a compiler error, and I think I should get a compiler error. No, compiles. You shouldn't put void in front of it. I don't know why it compiles. Weird. No, but constructors don't have return types. In Java, you can't specify them. It must be something specific to processing. But if you notice, if I put void player here, the sketch compiles, but it won't do anything. So it's wrong. You don't put void in front of the constructor. Never put the word void in front of the constructor. Never put anything. And it's the same name as the class, and it takes no parameters. So I'm not quite sure why you even compile that. It's something weird in processing.
Need to be where I suppose.
I see your.
I know.
You're going to in the right order. I have it. X plus half. I'm going to wait for minus. How do you have minus? Where did you start?
First this
Okay, so
line,
just
then
everybody,
this line, then
once
this
you get
line,
up to
this
this
line.
stage here, where you've instantiated the player, you've got the player in a separate class, we're calling the move method, calling the draw method. As soon as all that's working, we'll take a break. So everyone just finish that bit and get your player to reappear on the screen via an instance of the class, and then we'll take a break. How many people have got it working? Awesome. Let's take 10-minute break, right? We'll come back and do the next thing. Yeah. If anybody's still working on it, hang on, and I'll come down and give you a hand, right? What's that? Sure. Press the button again, it will usually stop. Sometimes you have to press the buttons a couple of times and make sure the red light comes on. Okay, so a couple of very important concepts before we move on. Alright, this is big stuff. This is what this course is all about. Everybody needs to make sure they know what a class is. Okay? Everybody needs to know what a definition for encapsulation. S-U-L-A-T-I-O-N. Everybody needs to know what a constructor is. Everybody needs to know what an instance is. And everybody needs to know what an object is. So I'm just leave those up there for a minute and take a second to write your definition. Put it into your code if you need to. Write a definition for each one of those things and make sure you're clear what it means. I'll write up a couple of other ones here as well. A method and a field. They're just terms I'm going to refer to a lot. So it's very clear, very important that everybody understands what they mean before we move on. I want to use them, and I don't want to use them and then people say, I don't know what you mean by instance there. They're just so fundamentally important to the rest of this course. Okay, let's go through these. A class. Can anyone give me a definition for a class? Yes, wonderful. That's all. Simple as that. It's the data and methods grouped together. What about encapsulation? What does that term mean?
Code self-sufficiency.
Sure. What it kind of means is just keeping the data with the methods that the data needs to operate on. So that's all encapsulation means. So if we look at our system and we see that we have players and ships and bullets, everything related to the bullet we will encapsulate into a bullet class. All right. What's a constructor? Somebody give me a definition for a constructor. Perfect. A constructor is a method that gets called automatically when an instance of a class is created. Doesn't return a value, can take parameters. Another question that's commonly asked is, can you have multiple constructors for an object? And the answer to that is yes. You can have as many constructors as you like so long as they all take different parameters. What's an instance? If I said an instance, what am I referring to?
An object created off a class.
An object created from a class. Alright?
Could it be from, or could you use off? No, like what's the term of when it's created off a class?
It's created from a class, if you like. It's created, the class is the template for the object, right? Once I define the object define the instance in the class, when I instantiate that class, that means that object will have all of those things that I've specified in the class. So if I specify it has a width and a height and an x and y, then every instance of that class has a width and a height and an x and y. And an object and an instance really are the same thing, okay? And a method and a field. What are fields? Somebody tell me what fields are. Yeah.
Different variables.
Yeah. Perfect. That's all. Fields are just a list of variables that an instance of class has. And then methods are just the things that the class or that instances of the class can do. Okay. So at this point, anyway, we have our player class here. Our player has an x and y, a width and a color. We're going to add one extra thing to this player class. We're going to add a second constructor. So now I'm going to specify a player where I can pass in the x and the y. Okay, everybody look up at the code here for a second, right? So I have a constructor down there that doesn't take any parameters and that gives the x and y the default values of half the width and the half the heights on the center of the screen. Here's a second constructor for this object that takes the width and the height as parameters.
Are you able to call them both the same?
Yeah,
How does it know which one?
great question. So here we have a problem where I've got two, yeah,
You want to know because you have variables in this one.
I have two variables, right? But the issue here is now there's two x and y's. There's the x and y parameters and the x's and y's which are fields in the class. So what I want to do is I want to take the x and y parameters and assign them to be the fields in the class. So the problem we have here is that they're the same name. So we need to disambiguate between the two different x's. There's an x parameter and an x that's a field. Does everybody see that in the code?
Yeah.
So you disambiguate that in the Java programming language by using this. Excellent. Okay. So I go this dot x is equals to x, and then this dot y is equals to y. Sometimes when people are learning programming, they go something like this: x equals x. That, of course, doesn't mean anything. It doesn't do anything, and it's it's okay. People make that mistake sometimes. What we want to say is that the field x is equals to the parameter x, and the field y is equals to the parameter y, and we use that by using this keyword called this. This is a reference to the current instance of the object. So that's what this is. It's a reference to the current instance.
Just one thing?
Yeah.
Maybe you have player twice, the capital player, to create it twice.
Sure, yeah.
If you have another one, and then you put that, say, float W, float H, how would it know which one you're sending variables to then?
Say again. Well, I'll tell you what. We can do a third one, and this time I'll do x and y, and then float W and float H. So now I have loads of different constructors
No, I'm not saying it's because they're the same. If you got rid of the X and Y on that one, the top ones.
from the first one.
Yeah, if you got rid of that X and Y, then how would it know?
Oh
Would it be
yeah,
an error
great
then?
question. How would I know which one to call? It wouldn't. You can't do that. You'll get a compiler error. In fact, you should get a compiler error to saying, because when you call the constructor, it doesn't know which one is the X and Y, which one to call. So yeah, you can't have ones. They must have the different types. Yeah.
Does it run all the constructors?
No, it will only run one of the constructors. It'll run whichever one you call. So in this example here, I'm going to go this dot x is equals to the x parameter. This dot y is equals to the y parameter. This dot w is equals to the w parameter. And this dot h is equals to the h parameter. So I'm able to create lots of different instances depending on which constructor I call. So now I have three different versions of the constructor. Let's come over here and make a different player. So let's call that player 1, player 2, player 3. That's player 1 equals new player. Player 2 equals new player. This time I'll pass in the x and y. So let me pass in 100 and 100. And now I'm going to create a third instance of that, and I'm going to use the 3 argument constructor for that one. So 100 and 100, and this time we'll specify 60 and 60 as the width and height. 60 and 70 as the width and height. So I've created my 3 instances using 3 different versions of the constructor. So they all will call different constructors when they're instantiated. And then down here I've got player move, player draw. So yeah, you can see there we have duplicated code. So much better would be to take those players and put them into an array. But let's just run the program now, and we should see now that we hopefully have. Huh? Why do I only have one? Player 1, player 2, player 3.
They don't have the height and width for the...
Oh, fair point. Yeah, okay. They do have it for the third one. So I should really go H equals 20 and W equals 20 there. Okay, fix the bug. Why is it not displaying?
Get that there, W20.
Possibly it's the color thing.
When I did that WH20, I got some weird shape showing up then.
Oh, that could be just because your drawing code might be. Okay, I think that's it because I think it's probably drawing in black. Yeah, there we go. Okay. So now I have 3 players. I wonder why that last one, the lines are not matching up there. Why is that not lining up?
Run that rig.
Huh? So I've obviously got something wrong in my code somewhere, my drawing code. Let's make it 60 and 60 then. I think it'll probably work if it's 60 and 60, which means that my drawing code must be slightly out. Yeah, so now I have 3 player instances. Okay, do you want me to take it a little minute just while everybody gets that code working? Or will we move on?
Moving, I wonder about the actual positioning of where they are. Right, can you okay?
Sure thing. So the important learning outcome here is to understand that we can have various different constructors for an object and we can construct them and pass in different parameters. Yeah.
Are they shown in the right place?
Probably, yeah, they look pretty
The way
okay.
you had it, they should be the exact same, I think.
Possibly, yeah. You can check your parameters against mine, but I mean, you've got 3 of them on the screen, so I'd say it's fine, yeah?
Yeah.
I'd say that's what's supposed to be happening.
Oh.
Okay, when everybody's ready, I need to show you something very important. Is everybody ready? Are your brains all ready? Because we're going to do something crazy here. Really crazy that's going to really mess with your heads. But it's going to be good. You're going to learn something very useful and important. Is everybody ready? I need everybody looking up, away from your computers for a minute, because I'm going to make a change to this program, and I want you guys to tell me what's going to happen, okay? Let's get rid of player 3 for a minute. Okay. So yeah, I'll just use player 1 and let's specify 200, 200. So now I've got player 1 at 200, 200, player 2 at 100. Actually, let's make these match up so that we can remember these. So that's 100 and 100. That's 200 and 200. And then when I run my sketch, yep, I've got my 2 players there and they're both moving around. Wonderful. Okay. Everybody happy with that? Are you ready for the crazy thing? Okay, what would happen if I did this? Okay. Okay. Here's some code. So first of all, a couple of interesting things here. I presume you've realized when we call a method, I use that dot notation, and that means player 1 dot move is going to call the move method on the player 1 instance. So when I do .x, this is the x component of player 1, and this is the x component of player 2. Does everybody see this? You know what I mean by when I do .x here? Does everybody understand what that means? Okay, so looking at that code there, the big question is, when I run this sketch, will I get 2 ships drawn or 1 ship drawn? Will I get a ship drawn at 300 and 400, or will I just get 1 ship drawn? I want you to study the code very carefully. And there's 2 possible outcomes here. There's 2 possible things that could happen. And I guess you can imagine what the 2 things are. And it's basically down to what that equals implies.
Compiler error one is a possible output.
Oh yeah, that's also a possible output. So study the code very carefully for a minute.
Get at least 1 ship.
You'll get at least 1 ship. But will you get 1 ship or 2 ships? Okay, how many people think you're going to get 2 ships drawn? Put up your hands. How many people think you will get 1 ship drawn? Put up your hands. You have to put up your hand, otherwise you're off the course. So you have to put up your hand for either one or the other. So we'll try that one again. Everybody look and come up with a hypothesis. I don't care whether your hypothesis is correct or not. We can test it out in a minute. How many people think we're going to have 1 ship? Okay, how many people think we're going to have 2 ships? Okay, run the program and see what happens. Type it in yourselves and see what happens. I better run it myself just to make sure.
Yeah, I think
Oh, there is 2, but they're on the same spot.
Yeah, that's what. What's
You do have 2, but they're on the same spot.
Do we have 2 though?
Yeah, it's the same one, just drawn twice.
The 2 ships are being drawn, but on the exact same spot. So
Oh,
it looks like
why
there's
are
one.
they though? Because I've set the x coordinates to be different for both of them. Huh? Player 1.
Yeah.
So, but I've done player 1 equals
No,
B player 1, then player 2
this
equals
has
player
fused
1.
the objects
So I still
together.
have 2 of them. I still have 2
Why is it not
somethings.
getting changed?
Run the program and see what happens. What
Why are
happens?
they not getting changed?
Because player 2 and player 1 are now the same, always. Every time you change player 1, player 2 is also affected.
How do you unchange?
Okay, how many people have run the program? Put up your hands. How many ships did you get? Okay, did anyone run the program and get 2 ships? So, what has happened here? Why do we not get 2 ships? Why do we only get 1 ship? Anyone, any ideas?
We graded the grids.
Huh?
Because you have 2 x.
Yeah, but they've got different values. You've got 300 and 400, huh? So they've got different numbers.
Is it not that it's drawing both of them but in the same place?
Okay, if it was drawing both of them in the same place, then what's the significance of me setting the x's to be different values for both of them?
Lose a player 2 to player 1, it means player 2 is now player 1 as well.
Ah, cool. Alright, say that again.
Player 2 is now player 1 as well.
Okay,
Kind of like-
that's the answer.
Kind of
Okay?
like a pointer, is it? Kind of.
That is exactly the answer, and they are, and you're exactly right in that they are pointers. Okay, everybody look up at this, and this is a very, very important concept, right? If these were integers or floats, it would be very clear that there are 2 values. There would be 2 integers or 2 floats, if these were what we call primitive types. But classes work a little bit differently in Java and in C#, right? And here's how they work. I need to rub that out. Oh, Lord, I can't here. Here's what happens when we run this code, okay? The very first thing that happens is I go player, player 1, and player, player 2. That's the first thing that happens. So now I declare this variable called player 1, and this variable called player 2. What are the default values for those? Like when I go player, player 1, and player, player 2, there's 2 variables created. What are their default values? Anyone?
Nothing.
Nothing. Their default values are nothing. In Java and in C#, there's this concept called null, which I'm sure you've seen in C as well. So both of these initially reference null. Nothing. Okay, you can check to see if they're equal to the value null, and there's a keyword in C# called null as well, or in Java called null. So that's what they initially reference, okay? Next thing that happens is setup method gets called, and I go player1 equals new player. What happens then is the reference that used to point to null now points to some player object over here. Okay, so now this has an X and a Y, and a W and a H, and a load of methods on it, okay? Next thing that happens is player2 equals new player gets executed like this. And now this has an X and a Y and a W and a H. Alright, if these were integers, the next thing that happens there is player2 equals player1. If these were integers, what would happen?
Copy the
I would just copy the values over from player1 into player2. Isn't that what would happen if they were integers? That's what happens. When you do an assignment, it takes what's on the left, copies it over to what's on the right. But what happens here is that these things here in Java are called object references. And they're similar to pointers. But what happens here is that the pointers are copied over. So when you go player2 equals player1, what happens is players2 pointer now points to player1's object.
And what happens to that other information?
Good question. What happens to player1? What happens to this bit of memory here? Overwritten by what? It's just there and there's nothing pointing to it anymore. So what happens to it? Nothing. It gets cleaned up. What's the cleanup called in Java? It's called garbage collection. Right? A-G-E. Collection. We've allocated some memory to store this object here. You guys should be taking your own pen and paper notes, or notes in your programs as well, because absolutely every single one of these terms you 100% need to know for your exams and for interviews, right? You need to know what garbage collection means and have an example of it on the top of your head that you can roll out if you're asked for it in an interview. What happens here is this object gets garbage collected. There's a low priority thread, a background piece of every Java programming called the Java virtual machine is running. And it's looking for these types of objects which have been created, but nothing is referencing them anymore. And what it does is it frees the memory for you automatically. And that's called a garbage collector in Java. And that's an example of the garbage collector in action. When I go player1.x, I am changing the 300 here. But you can see that because player2 is also referencing the same bit of memory, I'm updating both at the same time. Does everybody see that? Does everybody understand that? Hello? Yeah. Will you write that down, a definition for garbage collection? Garbage collection is a low priority, it's called a thread. It's a part of the program that is running concurrently with the main program. It's running at the same time, looking for examples of where you've created some memory using new, and that memory is no longer used anymore, or no longer referenced, so it frees up that object for you. And so now in this example here, both player1 and player2 are pointing at the same location in the computer's memory. When I update one, I'm updating I'm updating another reference that's also pointing at that object. Does everybody understand that?
How often does it execute?
I don't know. It's low priority, so it looks at a time when your program is not doing anything else, and then it tries to run. Occasionally, if you have a big Java program with lots of memory allocation, then your program will pause every now and again to go and do a garbage collection. And that's, I suppose, one of the problems with Java, is that sometimes you can't predict when this garbage collection is going to take place. But it's not a huge problem. On Android apps are, like they've got 4 cores and loads of memory and stuff like that. So it runs on a low priority thread on one of the cores. So it's not terribly...
Once nothing points to player 2 anymore, can you still recover it?
Nope.
Either way? Nope.
Once there's, how could you though? Because the reference is lost. You've no reference to it anymore. You need to keep a variable that keeps track of that reference. And once there's no variables to keep track of the reference, the memory is freed up.
You could put another player to point at it, then bring it back.
You could, yeah, exactly. But if you didn't, then it would... if you didn't have some variable which was referencing the object, the program tags it for garbage collection. Yeah?
explain like games like Minecraft that get very framey when it comes into a lot of
Possibly.
more intense variants?
I would think so, yeah.
When you mod them, you find a lot of the time like they get a lot more like intense when your CPU.
Right.
It doesn't make sense because there's not a lot visually happening.
Sure.
You just do the background, that's your garbage collections on.
Absolutely, and that's a really big problem for Java games, is this issue of garbage collection. Even C# games and Unity and stuff, you've got to worry about garbage collection as well. But C# is a different type of language, and it has a thing called a struct, so you don't have this problem to the same extent.
Can you manually call garbage collection?
You can, but there's no guarantee, according to the specifications of Java, there's no guarantee that it will run. I think to manually call garbage collection, you run this, and I think this will probably work in processing as well. System.gc.
So it's not as much coding as asking for light.
Now that may not work in a processing sketch, or it may.
How much help?
There you go. System.gc will execute the garbage collector for you.
How do you prove that? How do you prove that actually done what it meant to do?
What you can do is allocate a whole load of memory and then call system.gc and look at your memory usage on your computer using the task manager, and you should see when system.gc gets executed that a whole load of memory gets freed up. This is how memory is managed in Java. You know, Java has no concept of pointers because everything is done via the garbage collector for you. You can allocate as much memory as you like, and then you don't have to worry about freeing it up like you do in C or C++. The garbage collector will do it for you.
Allegedly.
Yeah, I know it does. It does. Like otherwise, you know, Java's been around for 20 years. Like, it's a very robust framework. And this is one of the reasons why people love to program in Java, because it's easy. You just allocate the memory. You don't have to worry about remembering it. You just trust the garbage collector to go and free it up when the appropriate time comes. Okay. Does everybody happy with garbage collecting and constructors? Because they're two more important concepts that we've got. Everybody happy? Okay. Next thing we might want to do is make our ship rotate. So, to make our ship rotate, we have to introduce a new concept, okay? And the new concept is about transforms. So the first thing is, there's actually an API call. It's built into the processing framework to do a rotation. And you just call rotate. And you pass in a certain number of radians, and it will rotate your sketch by a certain number of radians. So, the first thing we need to do is add an extra field to our player class. And the field we want to add to our player class is the rotation amount. Okay, and this way we'll get it to when we press the left and right keys, and our thing will be able to rotate. So let's go float. And I'm going to call this theta, okay? So we'll specify theta equals to 0 in the constructor. I'm going to show you how to do constructor chaining so we don't have to all this duplicated code. But I need to look up how constructor chaining works in Java because it's slightly different to C++. Just a different syntax. Alright, so now I have this additional variable on my player object called theta. And theta is going to tell me how much this is going to rotate. So simply here on my move command, when I press the W and S, I want to make modifications to the position. When I press A and D, instead of going x equals x minus 1, I want to add and subtract to theta. So the first thing we need to figure out is, are our rotations clockwise or counterclockwise? What would you think? Rotations have to happen either one way or the other. They are clockwise. So our rotations are clockwise. So when I press A, I want to do a clockwise rotation. So what I want to do is take the value of theta, and I want to add or subtract when I press A. Subtract when I press A. Because I'm going to do counterclockwise rotation when I press A and clockwise. And let's add a very small number to this. Theta plus equals to 0.1f. And then A should be theta minus equals to that, and then D should be plus equals to that. So I'm going to change that rotation amount there. And then we jump up to the draw command, and there's a few extra statements that I need to introduce here. First statement I need to introduce, in fact, let's just try it. Let's just try what happens if I just put rotate theta in there. Let's just see what happens. Okay, so rotate by theta radians, then do the draw. And we'll see what happens, and that might help us to understand how that rotation works. Now when I run the sketch, there's my guy over there. Let me just make sure that's the right position. Let me say,
Right,
get
and
rid
that-
of player 2 now. So I've got 100 and 100. Oh, yeah. Okay, there it is at 100 and 100. What happens when I press A and D? Look at that.
Rotates around the circle.
But that's weird. When I do mine, when I press A, the one that remember the one that it had underneath,
Sure, yeah.
it was splitting out at one point.
Ah,
Now it's not.
yeah, okay, look at that. Can everybody see what's happening there? So it's rotating, but what's it rotating around? It's rotating around the origin. Right, so when you do rotate, it'll always rotate around the origin. So how do we fix that?
Change the origin.
Yeah, well, that's one thing we can definitely do. Change the origin. We can translate the whole sketch to be the position. In fact, I don't know if you can figure this out, but this is basically what we need to do. First of all, we need to draw the sketch around the origin instead of drawing it around the position. So we need to change all of this code here. So instead of using x minus half width and y and so on, we just draw it around the origin. So instead of x plus half width, let's just do half width. So we get rid of the x's and y's and make them 0 and 0.
Maybe instead of rewriting all that code, change the values of x and y to 0.
Could do that. Yeah, that's a good idea. I kind of prefer to do it like this because it's clear then that the rotation is actually around the 0, 0. Alright, so now I've got rid of x and y there. When I run this, there's my spaceship up in the top left-hand corner. Now you can see it's rotating correctly.
See that the line how you're drawing it?
See, it's just up there in the top left-hand corner. All I've done is wherever I have x and y in my line drawing code, I just replace it with 0 and 0. Okay, does everybody see that? So now my rotation is happening around the origin. And my spaceship is drawn around the origin as well. So I'll give you a minute just to get that bit working, and then we'll do the next bit. Has everyone got a spaceship rotating around the origin?
Nope.
Okay, so the changes I made is I put in the theta variable, and now I'm drawing this guy around the origin, instead of drawing it around x and y, and it's rotating around the origin. You should definitely take a few notes as you're going along here, otherwise you won't remember any of this, okay? Seriously, you've got to take notes, right? Either write programs or take notes. You want me to run it? Is it? Yeah, sure thing.
Yeah, it's for the rotation can work on these transforms.
So do we get rid of float x and y then?
No, because we also need to move it into position as well, don't we? Like this is okay, just rotating around the origin is okay, but we also want it to move to a position as well.
Right.
Yeah.
You said there was only one shape, but there's two here in mine. And now that I'm rotating it, apparently there's two of here.
Do you have two instances still?
It's because one is rotating and the other is rotating.
Yeah, exactly. Yeah, you'll definitely get that. We'll need to add 2 extra APIs as well. Push matrix.
So should I stop something?
What's that?
2 players. Should I get rid of the second player?
Yeah, I got rid of the second player, yeah.
Completely like that.
Yeah, we'll put back the second player instance once we figure out, how to do these rotations correctly.
So is that minus half height or should it be 0 minus?
So half width and half height. That's going to be, over there, and then into 0 and minus half height, so that will be up. Yeah, okay. Might need to just double check those, make sure. 0 minus half height.
Player 2, the center.
Half width, half height. So the bottom left corner, center,
No, it's supposed to
center.
be.
It's
No,
minus half width.
it's supposed
I think
to
that might be.
Using it go back in eventually, there's obviously something
be. Did you remove all of them? All of the
Oh yeah, sure. 0 minus half height is 6.
Oh yeah, 0 minus half height.
My still isn't going around that first.
Have a look.
It's doing this. It's not actually going around the origin.
Okay.
I'm not sure why. I have all in 0. But all X and Y was put into 0.
Just let me have a look at your
I don't know what happened.
let me have a look at your sketch.
Because mine broke when I had to put second player into it.
You just have player 1 still, don't you?
This be changed.
Shouldn't make any difference because we're now not using the X.
Player 2 would only spawn for some reaon. There will be.
I'll have a look at it.
But it'd be this reason because I'm using the
Now we can't get neither.
W half H half stuff.
Shouldn't make any difference.
And it's width divided by 2.
Oh, I wonder, huh?
I use that to draw the.
No, it's correct. Mine has that and it's working.
I think it should work. And I'll tell you what, I'm going to do the last little bit here.
Remove the minus that you should have.
Okay, how many people have this bit working?
What minus? I don't have
The
any.
translate bit.
I never had a minus.
Okay, what bit are you guys still working on? Is there anything you need me to put up? Should I put up some different code here? Do you want me to show you the sketch, or is this okay? Huh? Yeah, sure. If I run it, what you should get is you should get the guy rotating around the center. Rotating around the top left-hand corner of the screen, like that. You won't really be able to see it.
Why is yours different too?
So everybody, this is the last thing. The last thing we need to do is
Make it so.
we need to do 2 operations. We need to rotate by that, but we also need to translate it. So
Oh, I know
translation
what mine
means
is.
moving it. Okay? So we need to do a rotation and a translation. Which should we do first?
Is that why? How do I fix that?
You do the rotation first and then translate it. Alright, so, but I think actually you have to specify these in the opposite order to which you want it to take place. So translate X and Y and rotate theta. I think this is the way you do it. I think this will do the rotation first and then the translation. And there we go. So I've obviously screwed up one of my lines.
The force should be minus half width.
Let's see if that works.
Oh, this is more down.
Yay! There we go. So now we're able to rotate it and hopefully translate it. Of course, it's not moving in the right direction.
What
Now.
did you
We'll have to
change?
use a bit of trigonometry for that. Huh?
What did you just change there?
I actually just had minus half the width and then half the height.
That's a modern.
I have one problem that I was doing this.
Sure. I'll come down now. Yeah, so translate X and Y and rotate. Just out of curiosity, you know, you can try doing the opposite order and you'll see that we end up doing this. So it is doing the translation first and then
Get
the
it to the
rotation
center.
if
Correctly.
you do the opposite order. So what we wanted to happen is we wanted to do the rotation first and then the translation. So you specify them in the opposite order. I think that's an OpenGL thing.
Oh, yes, actually rotated properly.
I'm not sure.
Okay, I'll leave that up, but that's basically it for today, okay?
Software engineering.
Sure. Sure, we have to get that. We need to use trigonometry to calculate the movement direction now, right?